Hello everyone, my name is Pandya Siddhi. I am CPA graduate student at Sacramento State University. Today I am going to give a presentation on newly emerging technology called ferroelectric random access memory, which is widely known as FRAM. Here, this is an outline for topics going to be covered during presentation. First, I will start with the introduction about semiconductor memory and their types. Then it will be followed by what is FRAM, different structure of FRAM, what are the materials going to be used, working operation of FRAM. Then we will be looking at the design and the computation of the ferroelectric transistor, recent developments and the application in the field of FRAM, and finally we'll conclude it. Memory devices are very important. Almost all laptops and mobile equipment use memory as a storage component. Memory performs high-speed operations and makes the device more scalable and highly computable. As we know, in recent years, the demand and the usage of personal devices have been increased and require some more advanced technologies in field of semiconductor. Here, this picture shows basic memory hierarchy. There are two types of memory, volatile memory and non-volatile memory. Volatile memory, which require external power to maintain the stored information and retrieve the data, while on the other side non-volatile memory do not require external power to retrieve the stored information. Static RAM and dynamic RAM fall under volatile memory type, while FRAM, MRAM and flash memory come under non-volatile memory. What is FRAM? FRAM has the same structure as dynamic RAM, but FRAM uses ferroelectric layer to gain the non-volatile property instead of the dielectric layer. In addition, FRAM uses ferroelectric material to store the data and the two electrodes as a capacitor to create electric field. As we can see in this figure, FRAM technology operates on the polarization of crystal elements to perform read and write operation. FRAM uses crystalline structure of ferroelectric materials. Crystalline structure has ordered arrangement of atoms and ions. There are two types of materials being used in FRAM technology. The first one is a PZT structure, which contains lead, zirconate and titanate as fundamental atoms. Most of the industry applications use PZT as a ferroelectric material. The second layer structure is SBT. When electric field is applied, crystal structure changes orientation and moves upward side. It is known as an up polarization state. While the direction of the applied electric field is opposite, it moves downside, called as a down polarization state. Ferroelectric capacitor can be built using two electrodes and PZT thin film as a dielectric capacitor. Electrodes are nothing but a metal plates. As we can see in this circuit, top electrode is connected to the positive voltage source, while bottom electrode is connected to the negative source. When the switch is on, current starts flowing through the capacitor and it creates electric field, which polarizes the ferroelectric material, and this procedure is known as a charging. When switch is off, electric field still remain in the ferroelectric material and that performs discharging. This diagram illustrates the relationship between the hysteresis loop and the charges that accumulates in the ferroelectric capacitor. To understand the principle of FRAM cell operation, We must first need to understand the transaction of the states in the hysteresis loop. Here 6 points are indicated on the hysteresis loop, which shows the condition of the ferroelectric capacitor. At points A and D, describe the polarization conditions when applied voltage is 0. Points B and E indicate states when the applied external voltage is equal to plus or minus Vc. And the final point C and F describe the conditions when the applied external voltage is maximum. When applying voltage from 0 to plus Vcc, polarization state changes around the loop from point A, B, C. In addition, when applied voltage is from 0 to minus Vcc, the state changes from D, E, F, while on the other side, when voltage is applied to opposite direction like plus or minus Vcc to 0, state changes from C to D and F to A respectively. When the maximum voltage is applied, the amount of charge Qs is referred to as saturation polarization. Writing 1 or 0 data to a cell required the application of voltage plus Vcc or minus Vcc to both the electrodes of the ferroelectric capacitor. Here this two figure shows the actual writing to one transistor, one capacitor cell. When the transistor is on, the word line is selected and the voltage is applied between the beat line and the plate line. Adding this voltage to ferroelectric capacitor causes data to be written. To writing 0 is accomplished by making bit line is equal to 0 and applying voltage on the plate line, while writing 1 is done by making plate line is equal to 0 and applying voltage to the bit line. Written data is retained even if the transistor is off. In other words, the data is non-volatile. Read operation. When reading 1 or 0 data from a cell before selecting the word line, the bit line must be precharged to 0 volt to retain the high impedance condition. When transistor is on and Vcc is applied to plate line, then the data can be read out. Reading 0 is performed when Vcc is applied to ferroelectric capacitor with the bit line is equal to 0 volts and the voltage applied to the plate line. Reading 1 is done by applying Vcc to bit line and the plate line. Ferroelectric field effect transistor, which is also known as FEFET. The structure of FEFET is the same as MOSFET, but the gate oxide is replaced by the ferroelectric material. When transistor is on and gate voltage is applied, the created electric field polarizes the ferroelectric material, which accumulates the charge on the surface and forms the channel. On the other side, when the transistor is off state, the created electric field changes the direction and polarizes the material in the opposite direction. FRAM offers several major advantages, includes speed, endurance, low power consumption, and security. Let's look at each advantage in detail. FRAM performs read and write operation on the address location symmetrically, which means the write and the read operation are done in a single cycle. FRAM can read a byte of data from memory just as fast as write a byte of data, which enhances the speed of FRAM memory cell. FRAM offers low power operation. It runs at the CMOS voltage and does not need a higher power circuit to operate. Because FRAM does not need a higher voltage battery, it is more environment friendly than the volatile memories. FRAM also has a very high endurance. FRAM technology is well suited for the applications that require frequent data login, backup, and long memory lifespan. FRAM is very secure. Other memories employ a charge accumulation principle, which require transistor turning on and off to store the zeros and ones of binary data, while FRAM does not use a charge accumulation principle, so it does not change the data that's stored in a FRAM cell structure and keeps the data secure. Here is a brief comparison between FRAM and other memory technologies. FRAM offers based of RAM and ROM. RAM, a random access memory, is a faster, but it requires constant power supply to store the data. For example, static RAM and dynamic RAM. While on the other side, flash and EEPROM has a slower operation, but it does not require power supply to store the data elements, whereas FRAM provides both the advantages, faster working operation and a non-volatile property to retain the data without the power supply. FRAM's high performance is crucial for the certain applications. For example, cards issued by the local governments, resident card, driver's license and passport. In addition, FRAM is also used in a transit card. FRAM is embedded inside the chip and performs read-write operation on the secure data storage. High-speed FRAM allows the faster transaction and improves the traffic flow. Other applications include credit cards, wireless communication in terms of SIM cards, and the broadcast of the television programs. During past couple of years, the semiconductor industry has released some applications using FRAM memory. Here we can see some of the recent developments based on the FRAM. Fujitsu has started a production of the 2 MB of FRAM. FRAM are now manufactured using 2 transistor, 2 resistor system. So in other terms, the size has been increased. The new development of 0.18 micrometer technology has faster feature of the 25 MHz of frequency and the low power consumption. In conclusion, FRAM is a non-volatile memory that uses ferroelectric materials to perform the operation and the storing the data. FRAM has a higher speed, more secure, and consumes less power. FRAM performs best in comparison with the DRAM and the flash memory. As per the recent development in the field of FRAM, we can say that the FRAM will create a milestone in the semiconductor industry.